Lesson 46, simplifying expressions with square roots and higher order roots. First off, let's go through what they mean by roots. When we find the square root of a number, we know that there are positive and negative roots. But when they're referring to the principal square root, then they're referring to the positive square root. And so whenever they're asking you for a number, like the square roots, if they don't use the negative sign in there, then we're just assuming that you're using the positive form of it. And when they're talking about higher order roots, this means more than 2. So here it says in a superscript n equals b, then the nth root of a b is a. Or if you have the nth roots of the square root of b, that's a. The n to the left of the radical sign, so this n right here, is the expression, in the expression is the index of the radical. So when they ask for the index, they're really talking about which root. The index is the integer greater than or equal to 2. So you'll never see a 2 where that n is, because it's assumed that when you have the radical symbol, it means the square root, so the second root. If it's more than 2, then they're going to put the digits. So if it's 3, that means the cubic root. Or if it's the fourth root, then they would put a 4 there. And then we're going to be looking at fractional exponents. And to write the fractional exponents, instead of using the radical symbol, you can raise it to a fraction. So if you were to raise 4 to the half power, that's the same thing as saying the square root of 4. Or if you were to say 8 to the 1/3 power, that's the same thing as saying the cubed root of 8. So just think of the fractional exponents as like the certain root that you're finding. So let's take a look at some examples. We need to find the square root of 64. We're both finding the positive and negative values. So the positive and negative value of the square root of 64 is a positive and negative 8. Next one, the square root of 9 is 3 times a negative would give you a negative 3. Next one, the square roots of 0. Square root of 0 is just 0, because anything times 0, 0 times 0 would give us 0. When we have fractions here, you find the square root of the numerator, and then you find the square root of the denominator. Square root of 4 is 2. Square root of 25 is 5. So we would have the square root of 4/25 would be 2/5. And the next one, the square root of a negative 36. This one actually has no answer. The reason why it doesn't have an answer because there's no number you can multiply by itself to get a negative number. Because in order to get a negative number, you need a positive times a negative. So that one, you can never have a square root of a negative number. Other examples, square root of 81. Square root of 81 be 9. Square root of 16 is 4 times a negative 1. It's a negative. Square root of 1 is 1. Square root of 49 64ths, so the square root of 49 divided by the square root of 64, this will give us 7/8. And the square root of a negative number, cannot find the square root of a negative number, so no solution. These other ones are no longer square roots, these are cubic roots. So the cubic root of 64. The cubic root of 64, we need to figure out what do we multiply 3 times to get 64. Cubic root of 64 would be 4. Now if you can't remember how to do that, you can use your calculator. So I'll show you how to use it on your calculator. I'll turn this on, and if I hit the math button, here you can see the cubic roots, number 4. So if I click number 4, so the cubic roots of 64, enter that in there, and you can see you get your 4. So if you have a calculator, you can make use of that to help you find certain roots of a number. Cubic root of -8. Now before, when we said you could not find the square root of a negative number, this one is a cubic root. So what can you multiply 3 times to get -8? Well, I know a -2 times a -2 gives me a +4. And a +4 times a -2 would give me a -8. So this would have to be a -2. And again, we can check by using our calculator again. If we hit the math button, go to number 4, and then we type in -8. And there you can see you get a -2. Cubic root of 125 ends in a 5. I know it has to be a 5. 5 times 5 is 25. 25 times 5 is 125. So cubic root would be 5. Cubic root of a -1000. I have 3 zeros, so I know the root is 10, but it's got to be a negative in order to get to a -1000. But here's a hint. If you have a negative radicand, and that's the number inside the radical symbol, if you are trying to find an odd index, an odd root, then you can have a negative root. Next one, cubic root of 1728. So here we grab our calculator again, hit our math button, hit number 4, cubic root of 1728 gives us 12. This would be 12. And then the cubic root of a -343. This would give us a -7. Then looking at the fourth root of 81. Well, I know that 3 times 3 gives me 81, so that's 2 3s. Or 2 3s gives me 9. Or 3 times 3 gives us 9, and another 9. 3 times 3 gives us 9. So that means 9 times 9 is 81. So this would have to be, the fourth root of 81 would be 3. And then the fourth root of -1. I have an even index here. So in order to get a 1, I have to multiply 1 4 times. But to get a -1, I need an odd number of negatives, and I don't. So this would be no solution. Fourth root of 16 would give us 2. 2 times 2 is 4. Another 2 times 2 is 4. 4 times 4 gives us 16. Next one, the fourth root of a -81. Again, I can't have an even index to get a negative radicand, so no solution. And then this other one, fourth root of 160,000. Now we can use our calculator for that one. You grab your calculator and you hit the math button. Here we want the fourth roots. Fourth root, so I can use number 5. Let me hit the hit the 4, and then hit the math. Number 5, and then 160,000. Got an error there. Let's try it without the calculator. Okay, the fourth root of 16 is 2. And then in order to get 2 zeros, groups of 2 zeros, I need a 20. So if you did 20 to the 4th power, we grab our calculators. You did 20 to the 4th power, so 20 raised to the 4th power gives us 160,000. So the fourth root of 160,000 would be 20. Now simplify these with fractional exponents. So these are just like what we did before. So remember, anything to the 1/3 power would give us like the cubic root of 216. So again, you can use your calculator if you need to do these. So you hit 216. This time when you hit the caret symbol, we want to use parentheses so it's 1 divided by 3. That's another way if you can't find the cubic root. 216 to the 1/3 power give us 6. Then negative 27 to the 1/3 power, this would have to be a -3, because -3 times -3 is 9. 9 times -3 gives us -27. The cubic root of 343 would be 7. -8 to the 1/3 power would give us a -2. And then the cubic root for 125 to the 1/3 power would give us 5. With a fractional 1/3, we're trying to find the third root. And then the fourth root of 10,000 or 1,000 to the 1/4 power would be 10. Can't find the fourth root of a negative number, so this is no solution. 625 to the 1/4 power, 625 raised to the 1/4 power. Would give us 5. Again, you can't have a negative roots when you are dealing with an even index, so this is no solution. And then the 81 to the 1/4 power, this would be 3. So let's take a look at some examples with application. A gift box in the shape of a cube has a volume of 3,375 cubic inches. What is the side length of the box? So volume of a cube equals side cubed. They told us that the volume is 3,375. We need to find the side. So to undo a cube, you find the cubic root of both sides. So if we take our calculator and we hit the math button, hit number 4, and type in 3375, you get an answer of 15. So the side length would have to be 15 inches. The box has a volume of 6,859 cubic inches. What is the length of the box, side of the box? So again, volume equals side cubed. We have 6,859 equals s cubed. We need to find the cubed roots of both sides. And the cubed roots of 6,859 gives us a side length of 19 inches. On the last one here, a sculpture in the shape of a cube has a volume of 1,728 cubic feet. What is the side length of the block? So 1,728 equals side cubed. Find the cubed root of both sides. So the cube root, 1,728 equals 12 feet. So that is our lesson on fractional exponents and finding the roots of certain numbers.